everyone, and welcome back to my R tutorial series. This is, of course, episode 2, and today I'm going to be going through some basic code in R, how to create objects, and we'll look a little bit at the different types of objects, and also how to start making vectors with your objects, and then also how to do stuff with them. So, last time I briefly brought up that we need code chunks in R Markdown in order to write code in them. So let's first look at how to actually make a code chunk. Now, as you'll see, I've got a blank R Markdown document here. So if you're following along, you can use the one from last episode if you did anything with it, or you can just make a blank one, or just watch and follow along. So to make a code chunk, let's click on this green C button up here. It's a green square with a C in it, and then it's got a plus sign on it towards the top right of your main working pane. So if you click on that, it opens a drop-down that shows all the different languages that you can write code in. In this case, we just want R. I don't have a whole lot of experience with any of these other languages. I've used Bash in small amounts, but I don't know enough of any of these to show you anything in them. So we're just going to use R. And again, that is denoted by this little R here in the curly braces. I'm not too worried about naming my code chunks right now. It's good for organization if you have a really long code markdown, but it's not necessary. So you have this new chunk. Now, an alternative way to open one is with the keyboard shortcut, which I use quite frequently. This is Control, Alt, and I. Now, on a Mac, it might be the Command button, Alt, I. I'm not sure if it's quite the same, but you can actually see that if you go into the Tools tab up here, and then if you go down to Keyboard Shortcuts Help, there's a huge menu of shortcuts. So for me, insert a chunk is at the top of the source editor section, and you'll see it's Control-Alt-I. It should show you whatever that would be if you have the Mac version installed. It should show you. So if you just hit Escape to get out of that, now you can also take a look and see what other commands there are that you can use shortcuts for. I haven't actually thoroughly explored that list, so there might be some that I don't use that I probably could be using. Anyway, now that we have a chunk, what should we put in it? We should start making some objects. Objects are the base unit of working in R. This is what you save values to do stuff with them. Now, you can name it whatever you like, and when you're making an object, you start with what you want to name it. So I'm just going to go really simple with this tutorial, and I'm just going to do kind of an algebra style variable, and we're just going to call it x. It can be whatever you want it to be. The only rule is that it cannot be a number. So I can't put 5 here and say I want that to be an object. It has to be like a word or a letter or a series of letters or words. You also can't have spaces in the name, but you can do basically anything else. So if you want to separate things like you would normally do with spaces, I recommend an underscore or a hyphen or maybe a period. But you cannot have spaces and you cannot have a number. Now I think you can put numbers in them. You can have x1 and that will be fine. But if you just have the number, like you'll notice it turns green, if you can see that. If I put 15 here, rather than x5, that's still white text, so that shows that it hasn't changed to a number. So keep that in mind. You can't name it just a number. So we have our name. Now we need to tell it that we're making an object with this. And to do that, we use something called the assignment operator, which is a makeshift arrow made from the less than sign, or maybe that's the greater than sign. I always get them backwards, and the hyphen. And that kind of makes an arrow pointing towards the name of your object that's saying, hey, I want to assign whatever value you put here to this name. And I'm just going to pick a number. You can put a number on this side because you're saying you want x to mean 5. So if you were to make an equation with this, you would then have, it would read x as 5 if you put x in there. It can be whatever you want it to be in terms of numbers. You can have 0, you can have -9, you can have any list of numbers here. The important thing is that you only have one value here to start. I'll show you how to make a vector which has multiple values towards the end of the episode. So we'll just start here with x being assigned to 2, or I guess actually it's 2 being assigned to x. And now, right now we haven't actually made the object, we've just written out the code for it. So to do that, we just need to run this code line. Now there's a couple different ways to do this depending on what else you have in your chunk. Right now there's nothing else in the chunk, so I can just run the whole chunk if I want to. And to do that, I just hit this green play button here, this play arrow. It says run current chunk if I hover over it with my mouse. So I can do that, and up here in the environment, you'll see it made x equals 2. And down here in the console, it will show you that you've run this code. This is like a history of code that you've run. You can also run code down here, but I'll show you that in a minute. The alternative way, if you have multiple lines of code, like let's say I make another object called y, and I want to assign that to 5, you can either rerun x is 2. It won't change anything because you've just said that x is 2 again, and it's going to stay as 2. But let's say you have something up here that takes a really long time to run, and you only want to run this line of code. You can either, if it's only one line, you can just put your typing cursor down here somewhere on this line, or you can highlight the code that you want to run. And when you do that, then you can hit Control-Enter, at least on a Windows computer. That would be the Control-Enter, or some people call that return. If I can type, that would be great. So you can also run it like that. So you'll notice there's a little green bar that comes up on the left there briefly. That's just to show that it's currently running that line of code. And you can just rerun them as you please. You'll see the history of which ones have run down here, and you can see up here that x is 2 and y is 5. And that's not going to change no matter how many times I run these unless I change the actual code. So now that I have some objects, we can do math with them since they're numbers. R is essentially a giant, super powerful graphing calculator, if you weren't aware of that. So you can do all kinds of math. You can do basic calculator math, of course. So you can do everything from x plus y, and that'll give you 7. Now this is not saving it to an output either. I could save this to another object. Let's say I want to make z equal to x plus y. Then that would give you z equals 7. Otherwise, you can just, if you just want the output to show up in the document, you can just do it like this, and you have 7. You don't need an object to run code. You can do, y minus x, and that'll give you 3. You can do, if you want to multiply, you just need an asterisk. It'll give you 10, and if you want to divide, it's just a slash. There you go, 2.5. Now, note that you don't need the space here. I just like to put the space here because it looks nicer. It's a little bit easier to read. So I like to put spaces, but you technically don't need any spaces at all. Again, you can't put spaces if you're trying to name an object. So let's say I wanted to name this x, I don't know, x number. But, this isn't even an object. I can't do it up here either, x number, x number, and it'll say unexpected symbol because it's not sure what number means. So get rid of that. You can have the space there at the end of it, but not in the middle of it. So this might seem a little bit unnecessary at this level of simplicity because you could just type in 2 plus 5 and get the same thing, but it will become necessary when you get larger equations or functions or some other thing that you're doing to the objects. And let's say you have a data set that you're bringing in from Excel or some other program that you want to apply that code to a whole bunch of stuff. So you can assign objects that are pieces of that data set and then do math with them. And that will save you a lot of time and effort. Right now I don't have anything like that to show you because this is just the very basics. I will get into that in a later episode when I start talking about actual data organization. That might be the next episode, or that might be the one after that. I haven't decided. So now that we have some objects and we know how to do stuff with them, we can start talking about the different types of objects. So right now we're working with numbers. These are numeric objects. They're just a single number, very simple. Note that R can handle any kind of number, and it will still be a numeric or maybe an integer class, which basically means the same thing. There's a minute differences, I think, but it's not that important in most cases. So R can handle negatives, it can handle 0, it can handle, it even has functions for infinity. If you want to do more complicated math, of course it has those functions as well. You can do exponents with the caret symbol, just a little up arrow thing. There's the log function, which this log function by default is natural log, so it's base e, but you can also make log 2 or log 10, and you just put whatever number or object in the parentheses. You can do the square root, which is just sqrt, and then the parentheses, so square root of x is that. You can do all kinds of different things. There's even more complicated functions for, say, derivatives or integrals, or the trigonometric functions, sine, cosine, tangent, all of those. You can do any of that stuff in R, and it can be very useful. Now, to talk about the different types of objects, there are numerics, of course, but then there's also something called a character object, and that would be a string of text, human language. And you can define that by putting something in quotes. So you'll notice I'm just going to start an object here called car, short for character, of course, and I'm just going to call it character, because why not? And you just put in quotes, and you'll notice that this is like bright green, it's a completely different color. And when I create that object by running this line again, you'll notice up here that it even shows it in quotes in the environment, and that indicates that it is a character object. So this, you can't do math with this, of course. I don't know how you would do math with a word, but you can also call numbers as characters. So let's say I wanted to make an object called number, and if I put it in quotes, like number 2, it'll show up in quotes up here, and it's not, you'll notice that the numeric version of that does not have quotes. So you can't actually do math with this object called number. So if I were to say x plus number, it says it's a non-numeric argument to binary operator. The binary operator being the plus symbol, so it's trying to do math, and it has a non-numeric argument, that being the number object, because it's a character. Now, if you wanted to switch between these classes of objects, you can simply do that with a command if you don't want to redefine the object. This is more helpful when you have data coming in from like Excel, and it sometimes gets it wrong and thinks that a number might be a character or something similar to that case. And in that case, you can simply redefine the object. So let's say we wanted to keep it named number, but we wanted to redefine the original number, which is the character version of 2, and say we want this to be a numeric. So we use the command as.numeric, then in parentheses, the old number. So this is the old number object, and we want to use the as.numeric command, and then we run that, and now, watch this. Now we can do this. X plus number, 2 plus 2 is 4, because now in the environment, number shows up as 2 without the quotes, meaning it's a numeric object. So that's just a very kind of simplistic way to change some things about an object. Now there's all kinds of different classes of objects. So we've got numeric, we've got character. You also have Boolean objects, so if I wanted to make one of those, I'm just going to call it bool. That's Boolean. Actually, I'll just call it Boolean. And that consists of either true, these have to be in all caps, by the way. It can be true, false, or NA. And you'll notice they change color there. You can also simplify the true and false by putting either big T or big F. Note that little t and little f do not work. You cannot have this in lowercase, although R thinks you might want the Boolean version, so it will change it for you. Now, a note on NA. A note on NA. NA can fill in for just about any kind of object if you have a blank value there. R does not tolerate blank values very well, especially if you're bringing data in from Excel. You will want to avoid NAs if possible. Sometimes, if it won't mess up your data too bad, it might actually be better to put a 0 just so that it's all numbers and it won't mess up any math. But if zeros are out of the question because maybe they will mess up your math, you can put in NAs and then you'll just have to find some way to filter them out so that it doesn't actually affect what you're doing. But you can replace, if you have a series of items in an object in, say, a vector, which I'll talk about in just a moment, you can replace something in there with an NA and it will still function as that same class. It just won't function for math, etc. Now, just a couple other things about classes before I move on. There's all kinds of classes. You can have lists and doubles and arrays and functions. If you make your own function that is its own class called function. A lot of those are rather complicated and probably beyond me to properly explain, but just know that they exist. And if you ever want to know what class something is, like let's say you're given somebody's code or you're working with something that you're just not quite sure how it's being put together by R, by some command that you're using, you can use the class command and just put in whatever object. I'm just going to put Boolean in here in the parentheses, and that will tell you, this is a logical, that's the other name for a Boolean object. So logical just means it's true or false. If I wanted to know the class of number, remember we changed that to numeric, so there's that. If I wanted the class of car, you get character, so that's a character object. And if I were to do X or Y, it would give me numeric as well. We'll get into more complicated objects a little bit in the future. Right now I'm just going to keep it simple, just to show you kind of how R is wording things and how R is set up to actually work with objects. Now, if you want to have more values, more than one, in an object, which most of the time you do, not always, but most of the time, you want what's called a vector. And I've said this word a bunch of times so far, and you may, if you have no experience in R, you may not know what it means. A vector is simply an object with a series of values of the same type in kind of a series, in a list. So, not to be confused with the list type of object. It's a little bit confusing. So, if I want to make a vector, all I have to do is concatenate. That word is concatenate. And that means to just put together multiple values of the same class. They do have to be the same class to be in a vector. So if I want to make a vector just called vec, let's say I want to make a vector of numbers. The concatenate command is just C, which stands for concatenate. How convenient. So if I want to make a vector called vec of numbers, let's just say I want the even numbers, 2 through 8. So 2, you just separate them by commas. 2, 4, 6, 8. Parentheses. So you're concatenating 2, 4, 6, 8 into a vector. And now when I run that, you'll see it actually tells you what class it is in the environment. So vector of numeric class. These in brackets just tell you how many items are in that vector, how many entries. And there's 4, of course, 2, 4, 6, and 8. And it tells you what they are. Sometimes if you have really long vectors, like if I were to add a couple to these and make it longer, you'll notice it kind of goes off the screen. If you want to see what's in an object or a vector, you can either expand this so that it shows you all of them, but if it's still too long, you can also just type the name in. Either here and just run it and it'll tell you right here, or you can just type the name of the object down in your console and it will do the same thing down here. That's kind of what the console is for. It's just like temporary code that you don't need to save because maybe you don't want the document to show this, but you want to save it as an object and then you want to say, oh wait, let me make sure that ran correctly, and then you check down here and that will not show up in your final document. So it won't be saved, so if you need something that you need to remember, then you probably do want to put it in here. But if you just need temporary code, you can use the console for that. So let's see. So I can also do vectors of different classes. You can do, let's say, I'll call it C-vec. Again, you can use hyphens or underscores or periods or something to use instead of spaces because you can't have a space in an object name. So if I want to make another vector, that this time it's a character vector, you just need to put everything in quotes, and again, you separate by commas. So I'll put, hi, my name is Nathan. And those are all, Oh, actually, I stand corrected. You can't put hyphens in object names. So we'll call it C.vec. My mistake. So now I have each of these as an entry to this vector. So there's 5 entries in the vector called CVec. You'll see it up here. The class is CHR, or character. And there's 5 items on it, and it's all, hi, my name is Nathan. You can do that with any kind of string, as long as it's in quotes. You can even do it with numbers in quotes, just like I did up here. That doesn't make a whole lot of sense, and usually you don't want to do that. You usually want the numeric version. You can also use the as.character or as.numeric commands with vectors. They work similarly. Just a note of warning, don't do this. Let's make another one just to show you. Don't try to mix the classes in one vector. So if you concatenate, let's say you want 2, true, and hello in a vector. What do you think this is going to do? You got a numeric, logical, and a character. This is going to turn it all into characters. So if I do that, you'll see up here, V is CHR with 3 entries, and they're all in quotes. So that completely removed the mathematical properties from the 2, the Boolean properties from true, and kept hello as just a word, but it turned these also into words. So if I say class V, it's character. So you have to be careful with that, especially if you're working in Excel. You have to make sure that if you have a data set, that all of the items that will be put together in vectors are going to be in the same class. And I will show you how to do that in a later episode, but for now, just keep this in mind with your vectors. So I think that's going to do it for today's lesson. I hope this has been useful. Some upcoming lesson topics, I'm not sure exactly which order I want to do them in yet, but I think the next couple will involve matrices and data frames and different types of data, which will be kind of an expansion on the topic of vectors. And then also, I'm going to look at file organization, how to import and export Excel data, and different file types, and maybe also just kind of looking through the file system in R. One last little thing actually before I go. If you want to get rid of all of the objects you have saved currently, not the code itself, but just all of the objects that are in your environment, this will get rid of everything, mind you. So everything that's up here, you'd have to rerun the code to get it back. But you can hit this, there's a little broom icon up here in the top middle of your environment. If you click on that and you say, it'll warn you, and you say yes, boom, it's empty. There's no objects left. There is a similar function down here in the console, although, of course, this stuff is a little less important unless you like to scroll up through your history. You can use the up or down arrow to go up or down. But you can also hit this little broom icon in the top right of the console pane, and that will clear everything, I guess, that you're not on that line. So there you go. All right. Thanks for watching.